Hey, my name is JosephBajor, and today we're going to be talking a little bit about AI, specifically about a form of AI called deep learning. Now, before we really get into that, let's talk a little bit about what AI actually is in this context.
AI is actually a general term used to describe pretty much any system that could take input and make reactive decisions. This includes everything from the super simple hand-coded AI in early video games to the more cutting-edge examples we're going to be discussing today. In media, most of the time when they mention AI, they're not talking about hand-coded solutions though. They're usually talking about some form of machine learning, any system that is able to not only react to input, but also adapt to it. Today we're focusing specifically on deep learning, the machine learning method that is behind most of the newsworthy breakthroughs and media attention that you see today. So what is deep learning? The simplest answer is that it's a machine learning method that makes use of artificial neural networks to recognize patterns in a supplied pool of data. This is a method that can be used for many tasks, but tends to perform better than everything else when it comes to more complicated tasks like image recognition. Like I mentioned earlier, deep learning is a process that uses neural networks, which are essentially large webs of nodes organized in layers. Each node takes multiple inputs and provides one output, similar to an actual neuron. The node has weights associated with each of these inputs, which dictate how much attention it should put on the data coming from each of the other nodes. Each node also has something called an activation function, which controls how and when the node outputs data. Now let's look at how these nodes might look within a deep neural network. There is the input layer, which takes in the initial data, like the RGB values for a pixel image, for instance. And then this input layer outputs to another layer of nodes in something called the hidden layer. This is just a layer of nodes that we don't directly interface with. There are multiple hidden layers in a neural network, and within a deep neural network used for deep learning, you have a minimum of 3 of these hidden layers. The last hidden layer feeds into an output layer. Each of these nodes is connected to every other node in all of the layers on either side of it. So you can see all these lines here now. These all represent a connection from one individual node to another, and therefore each of these lines has its own individual weight associated with it. These weights and the activation functions I mentioned earlier are what allows a network to function better than a simple decision tree or linear regression model. And the values of all these weights are actually how the network memorizes things, and how they're changed and molded during the training process is how the network actually learns. So now that you know a little bit more about how the deep learning process actually works and how it's able to kind of extract these deep patterns from data, let's talk a little bit about what this actually means for the field of healthcare. There are already plenty of instances where deep learning based systems are either being used in practice or being explored. One example is in the detection of things like tumors through live camera feeds that help doctors detect issues that they might not have otherwise seen. Another possible area of benefit is in the field of epidemiology, with deep learning based systems able to detect anomalies in infection spread that might have otherwise been missed by other early warning systems. Deep learning can even help with drug discovery, as shown by the recent success of DeepMind's AlphaFold 2 with protein folding simulations. This is an area where deep learning is not just helping us speed up or automate something we were able to do before, but it's enabling an entire new area of research, where we were never really able to simulate protein folding in a practical way before this breakthrough.
Every single day we discover even more about what these networks are capable of and the kinds of information that they're able to work with. The most important thing to understand is, like us, these networks are pretty good at finding deeper, less obvious patterns in these really large data sets. And right now, many see the technology as just kind of playing a supporting role in much of the field, but I believe that with the rate of progress we have seen, soon we'll be able to use deep learning to gain a lot of insight into areas that we really never would have found much information ourselves. It's a prospect that many find inspiring, some definitely find it frightening, but regardless, I hope that I helped you understand a little bit more about the field and why it's such a topic of interest for so many.